With the main collisions done, the game starts to take shape. In this session we will introduce the explosion animation, the audio of certain elements, the alien instantiator, and we will also fine-tune some details. Given that the project is becoming complex, it is wise to precisely list what we will accomplish. It is essential to prevent the player from leaving the screen while playing. The player's script should limit the position values. When we destroy an alien, there needs to be feedback. We will create an explosion to make the target disappear. When it explodes, the explosion should be heard. This is the perfect time to discuss adding sounds to the game, and on the same topic we can also add sounds to the lasers and eventually a background music. For the game to be more dynamic and unpredictable, we need more aliens. To do this, we will create the alien spawner script to automatically place aliens in the game. Lastly, we must control how long it takes the alien to start flying and shooting. This is crucial to keep the boss out of the frame without shooting while the level is ongoing. All of this will mean changing and adding code to some scripts we have already developed, but also creating new features and learn new concepts. To limit the player's movement, we need to specify the horizontal and vertical boundaries, and then limit the position to those values. In fact, this problem is straightforward to solve. In the player script, we declare 4 variables to define the minimum and maximum positions for the x and y axis. Then, in process, we use the math function clamp method to reposition the player. This method expects 3 values. The first is the value to change, in this case the position, the second is the minimum, and the last one is the maximum. What happens is the player is moved to where the previous instruction calculated, but before the frame is drawn on the screen, the clamp forces the position value to stay within the set limits. Since this happens before the frame updates on the screen, we don't see the ship going forward and returning within the limits. In Godot, all that's left is to set the boundary values. We manually move the player to one corner and see in transform which numbers we put in the variables. We drag the player to the opposite corner and do the same. On the x-axis, the value should be the same, just changing between negative and positive. On the y-axis, we should also alternate between positive and negative, but the values should differ because at the bottom it goes up to the game window's limit, but at the top it doesn't. We test to check if it's working and move to the next. We create a new scene, change its name to Explosion and save it under Elements with the same name, Explosion. We add a sprite 2D with the All Sprites texture. The explosion is an animation with 8 frames, situated at the bottom of the sprite. When setting up the region, we should use the full width, but adjust the height so that when sliced into rows, it doesn't cut off the lower frames. If we set the height in such a way to keep this control point above the lower frames, we will cutting it correctly. In animation, we define 4 horizontal frames and 2 vertical ones. When changing the frame, we should see the explosion taking place. The last frame is intentionally empty, so that the image remains clear at the end. For the animation to play automatically, we need an animation player. In this node, we create a new animation called Exploding. We add a property track and choose the frame property of the sprite 2D. Next, we go to the sprite 2D, add all the frames, set the animation time to the end of the last frame, and enable the autoplay on load option. The speed scale can also be raised to 2 to make the explosion a bit faster. To finish, we set the explosion's Z index to 101 and set the frames to 7, so the element has a representative thumbnail. To add sound to the explosion, we need the Audio Stream Player node. In the Sound folder, we select the explosion sound and place it in the Stream variable. We should also adjust the volume to -3 and activate the autoplay option. As this player is in the explosion scene, the autoplay option will start the sound as soon as the scene appears in the game, making the sound begin immediately after the explosion is instantiated. However, like all other elements, once it's no longer needed, the element should be removed from the game. This detail often goes unnoticed, as the last frame is empty and the sound doesn't loop. At the end of the level, we think we have an empty universe, but in reality, dozens of nodes related to previous explosions are still being processed. For this reason, we should remove the explosion scene as soon as we no longer need it. In Explosion, we create a node to be named Element Remover. We also create a script with the same name. In the Element Remover script, we need a variable for the delay, another for the count, and another to house the root node of the element. In Ready, we assign the parent to the main node variable, and in Process, we count the time and check if the wait time has been reached. If so, we remove the main node. If there is a need to automatically remove another element after a time, we simply add this structure and adjust the time in the variable. However, to avoid searching for this scene to copy the structure, we will turn it into a scene that can be simply added to another tree. We right-click on the element remover and choose Save Branch as Scene. Here we create a new folder named Tools and save it as Element Remover. This way, Element Remover is always available to be added to any other scene. Now all that's left is to place the explosions when the aliens are destroyed. To instantiate explosions, we need to modify the script where the elements are destroyed. In the case of aliens and the player, it all happens in the health script. In the decrease health method, we have the condition that triggers the removal of the element. It's precisely at this point that we should insert the explosion. If we instantiate the explosion here, it will appear at the moment the alien or the player vanish, giving the sensation that it exploded. For this, we need a variable to store the explosion's reference. We will only instantiate the explosion if the variable holds a value. The health can be used in various elements that might not need to explode, and to prevent errors due to lack of the value in the variable, we add a condition to confirm if the explosion exists. If so, we proceed with instantiation. Explosion different from null checks if the variable has a value. If it's empty, its value is null. In Godot, we initialize the variable as null. However, if we assign the explosion reference to the variable, it will be available and instantiated when the alien gets destroyed. Testing the game, we see that the alien without an explosion is removed error-free, and the one with an explosion vanishes with a bang. The next step is to add explosions to every element that needs to explode, including all the aliens and the player. The laser should also make a sound, but we will approach this in a different way. To prevent multiple identical sounds from being instantiated at the same time, due to the multiple cannons firing at once, we will give the cannon the ability to instantiate a laser sound, but only if it is configured. We start by creating a scene called Laser Sound that includes an audio stream player. It should contain the laser sound set to autoplay and at -6 decibels. We also need to add our automatic element removal tool. In the player cannon script, we declare another variable for the laser sound, and at the moment of instantiation, we add another instantiation process. This will operate on the laser sound instance variable and will instantiate what is stored in the laser sound variable. However, since we want the sound to be instantiated only if it exists, we use an if statement to check if the variable is not null. If it is different from null, we execute the code. If it is empty, the instantiation process is skipped. We implement this check to ensure that only one cannon produces sound and to avoid errors due to the other three cannons being without associated sound. If we run the game as it is, it should get the previous behavior. We fire in silence and no errors appear in the output window. However, if we add the laser sound scene to one of the cannons in the player scene, we will hear a sound with each weapon fired, but not 4 sounds at the same time. Another critical aspect of the player's experience is their ability to defend against enemy lasers by firing their lasers against them. In reality, we already have all the elements needed for the lasers to destroy other lasers. We just need to assign groups to the lasers and ensure they have health. This is an excellent opportunity to make our health node as a handy tool. If lasers have health and belong to the right groups, they can neutralize each other. To ensure they destroy themselves quickly, the life should be set to a low value. To make the interaction even better, we can access the explosion scene and save it as a new scene. We rename it as Explosion Mini and adjust the scale of Explosion Mini's sprite 2D to 0.3. For the audio, we decrease the volume to -10. By adding the Explosion Mini to the laser's health, we can see that they also disintegrate with a small explosion. The game level can be manually designed. The alien's position can be pre-made by simply placing the aliens on the map above the camera. However, the level will be predictable, and if the player repeats the game, they will know where the enemies appear. This is not a problem. For example, Super Mario has pre-designed levels, and this even creates a new game model, like the speedrun. In the case of our game, we will have an automatic system for spawning aliens to create unpredictability and random levels. We create a script called Alien Spawner and add it to a 2D node on the alien boss. We place it here so that the spawner disappears when the boss is destroyed. For the alien spawner to work correctly, we need a defined set of aliens that can be instantiated, as well as specific coordinates to control where these aliens appear on the screen. The height position should be off-screen to give the illusion that the aliens are entering the screen, and the width should be randomly defined to create a more dynamic experience. To store and manage this set of aliens, we can use a data structure called an array. We declare a variable of type packed scene called aliens. If we put square brackets after the type, we are transforming the variable into an array. An array is a collection of elements of the same type arranged sequentially. An array can be compared to a bookshelf, where each book is an element and each position on the shelf is represented by an index in the array. So, if we want the third book from the shelf, we take index 2, since the array starts counting at 0. In Godot, in the inspector, we can see that we have the variable empty, but with the possibility of housing several elements. To read or modify a value within an array, we use the index of the element. For example, to access the first element of the aliens array, we write aliens 0. If we want the second, we use aliens 1, and so on. In Godot, we can add two elements to the array, alien 1 and alien 2. The script will also need to know the wait time to instantiate the next alien and a variable to count time. As for the alien's position, it should be above the screen, but randomly across the entire width. Thus, we declare a variable for the y coordinate and two other for the maximum x and minimum x. For this process, we start by counting the time and check if it has reached the waiting value. If so, we reset the counter to start a new count. Choose a random alien from the array and instantiate the chosen alien. Just like lasers, after being instantiated, we need to place it in a position. First, we define the random position of x within the defined limits and update the position to the coordinate with the x and y already set. Finally, we set the alien as a child of the main node of the level. To pick an element from an array, you need to give the index of its position with an integer. When we select one of the aliens, the random command chooses between 0 and the value entered in the argument. In this case, the argument is a count of the number of elements within the array. This means that regardless of the number of aliens we have, random will always choose an existing value. When we instantiate the alien, we use the alien to spawn variable as an index. This contains a random index within the limits of the array, avoiding errors. For the position, we use the same technique, but here we provide random with two values, one to define the minimum and another to the maximum, with the minimum not necessarily being 0. In Godot, we must ensure that the coordinates are within the system. The y must be above the camera and the x within the limits of the image. When running the game, we should have aliens appearing every second and a half in a random position until we destroy the boss. Since the boss houses the alien spawner, as soon as we destroy it, there will also be no more aliens. Now that we have the functional alien spawner, we can state that the alien boss is responsible for creating the other aliens, and we must keep it out of the player's laser range so that we have to face several aliens before the end of the level. What we need to do is to delay the boss appearancing. To achieve this, in the alien script we had two variables, one to keep track of time and another for the waiting time, both with a 0 value. This value ensures that all aliens start moving immediately after appearing, avoiding the need to configure each alien individually. In this case, we only need to set up the boss. In the process method, we increment the delay count value, and if it's greater than the waiting time, we execute the command that moves the alien. This way, the movement is only processed when the time passes, and the element won't move before that value. In Godot, in level 1 scene, we change the alien boss delay to 10 seconds just to test. When we run the game, we can see that the alien boss waits 10 seconds before it starts to move. Great, but there is a problem. As we can see, the boss, while waiting, fires its cannons from the start. This is a problem because the player has to deal with lasers of an element that cannot fight. The solution is straightforward. We add the same delay functionalities to the alien cannon. In the alien cannon script, we introduce the same variables, changing the name from delay to move to delay to start shooting. By adding the new counter and combining the delay within the existing if statement, we will have the cannon firing at the regular intervals but only after the waiting time has passed. In Godot, within the alien boss, we select all cannons and change the delay to 20 seconds. This way, the boss waits 10 seconds to enter the screen and another 10 to start shooting. Copy the entire content of this lesson. Adjust the speed of the element so that the gameplay is dynamic, challenging, and interesting, but not impossible to beat the boss. Create two scripts named background stars and star movement. Copy the code provided at the end of the video. Analyze the code of both scripts, understand them, and figure out how to implement them. Using this piece of explosion as a region for the sprite, create a star field similar to what is being shown now.